Ignition sequence start.
I can't wait until NASA calls about our mission into space.
Yeah, it'll be great.
I know we're the best candidates NASA's got.
Yes, but all astronauts need to be sure they're both mentally and physically prepared.
Watch how I blast off these push-ups. Count them off.
Okay, that's one. And keep going, Malcolm. And
Whoa, must be the backpack. It's slowing me down.
well, we'll have no excuse when we're up in space. How's your mental preparation? Do you know the answers to the big space exploration questions? Like, how is space explored?
What are its limits? How far can we travel?
And what was the space race?
And how much of the universe have we explored?
Come on, let's get started.
Okay, so they're not real astronauts, but hey, they might be someday. Whether it's simulating a mission, practicing a spacewalk, or a walk on the moon, or seeing what it feels like to tumble in a spacecraft, this is the kind of training that real astronauts do. So what do you think? Do you have what it takes?
That's 1 minute, and you still haven't completed one sit-up, Malcolm. You're not gonna use that backpack excuse again, are you?
I think my insides are about to explode.
You see that up there? There's an awful lot of space to explore, and in order to do so, we have to be the best of the best. Lots to do.
Can't we rest for a second?
No time to rest. We've got to explore like the many brave men and women before us.
Oh, man.
Since the beginning of time, people have wondered what's really out there. Long ago, ancient astronomers tried to chart the positions of the planets in the sun by simply scanning the night sky with their eyes. Finally came the invention of the telescope.
The instrument that changed astronomy forever.
Italian astronomer Galileo Galilei was the first to point a telescope at the night sky. With it, he discovered 4 moons orbiting planet Jupiter, and he could see the surface of the moon. As technology became more advanced, telescopes got bigger and better. Huge telescopes housed in mountaintop observatories allowed us to see up to 3,000 times further into space than with the naked eye. But it wasn't enough. The more we learned about space, the more we wanted to know.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
The rocket was our ticket to outer space. In order for a rocket to lift off, it has one major job to do. It has to defy gravity, the overwhelming invisible force that, on Earth, pulls everyone and everything down toward the ground. Unlike an airplane that gets off the ground by using lift created by the shape of its wings, a rocket uses brute force and a lot of fuel to push itself straight up. It goes from standing still to traveling at 11 kilometers per second. That's 7 miles every second.
You know, rockets are complicated machines. They basically use the force of an explosion to lift off. Pretty risky, especially when you're trying it for the first time. No wonder early test flights were almost always performed without astronauts on board.
Yes, rockets can be extremely dangerous. In most rockets, the payload, the part that goes into orbit, is only a tiny part of the whole rocket. The rest is primarily fuel tanks, filled with thousands of tons of tremendously explosive fuel. These gases burn fiercely in an area called the combustion chamber. And under very high pressure, the gases escape through a nozzle at the bottom. This creates the thrust that propels the rocket upward. Take the Saturn V, for example.
It was the most complex, technologically advanced monster rocket ever built. 111 meters, weighing in at 3,000 tons loaded with fuel. 5 engines pushing out 7.5 million pounds of thrust. Yeah, baby!
Settle down, big fella.
Woo!
You can see how scientists measure thrust by making your own small rocket and rocket fuel. You'll need a clean, empty 1-liter soda bottle, a cork to fit the bottle, about 50 centimeters of string, a stapler, some vinegar, a spoonful of baking soda, a paper napkin, a scale, and safety goggles. First, tie one end of the string around the neck of the bottle and staple the other end to the cork. Then, pour the vinegar into the bottle. Wrap the baking soda in the napkin and twist it closed. Then, place this napkin and the bottle on the scale. Make note of what it weighs. Now, get ready for some action. One of you must watch the reading on the scale. Carefully put the napkin inside the bottle. Then quickly push the cork in the bottle without jamming it in too hard. Then step back. Make note of where the needle hits its high point. The difference between this weight and the weight before the launch is actually the weight of the thrust you created. By mixing vinegar and baking soda, you created a gas fuel, a chemical reaction. The air molecules inside the bottle expanded and created a force. The force became so great that it not only pushed the cork out, but also pushed the bottle down. That's pretty much how a rocket works, but in the other direction. Thrust is created upward when the fuel inside burns and explodes out the bottom of the rocket. As the pressure escapes downward, the rocket is pushed upward.
Ready?
Ready. Huh. Ah! As the first man to step on the moon,
Hey, wait a minute. You said you wanted to play Buzz Aldrin.
so
So, I'm playing Neil Armstrong, and he was the first man on the moon.
don't be such a baby.
I'm not being a baby. I'm not. It's just that you can't rewrite history. Let me tell you how it all started. It was the beginning of the space age, 1957. The former Soviet Union launched a satellite called Sputnik into orbit.
That must have been a big deal.
Very big. Nothing had ever been sent to space before, and the Russian scientists had gotten the satellite up first, something the Americans were not yet able to do. So now there was a new goal. If a satellite could go into space, maybe a human could go too. The space race was on. So while the Americans tried to catch up in the race to space, the Russians reached another first. In 1961, cosmonaut Yuri Gagarin became the first person to travel into space.
Score that. Russians too. The rest of the world, zip.
Now the pressure was on big time, and President Kennedy of the United States put the Americans to the test.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
After years of research, the Americans unveiled the giant Saturn V rocket that would eventually carry the crew of Apollo 11 to the moon.
Houston, Apollo 11 and Saturn gave us a magnificent ride.
Millions of people around the world were glued to their television sets to watch this historic event. And on July 20th, 1969, history was made.
Okay, Neil, we can see you coming down the ladder now. There you go.
Astronaut Neil Armstrong, followed by Buzz Aldrin, became the first human being to set foot on the moon.
It's one small step for man, one giant leap for mankind. They've got the flag up now, and you can see the stars and stripes.
The astronauts spent 3 hours on the moon's surface before returning to Earth. 3 days later, they landed safely in the Pacific Ocean.
I'm ready.
The rockets we've seen so far, like the Saturn V, are cool. But the problem is they were not reusable. That's why the space shuttle was designed. It's launched on a rocket, orbits the Earth, then lands on the Earth like an airplane. And after a little touch-up work, it's ready to launch again.
Now, as any good astronaut knows, our spacesuits are our most important piece of equipment.
Yup, because they protect us from the extreme environments of space. Kinda like long underwear does on Earth.
I'm Catherine Thornton. I was a mission specialist on 4 space shuttle flights.
We just wanted to say hi to everybody.
During my time as an astronaut, I also had the opportunity to do 3 spacewalks. Everything that you need to live needs to be in the spacesuit. It has thermal protection layers because if you're pointed toward the sun, it can get very, very warm. If you're pointed to deep space, it can get very cold, and so it has to protect you in both those extremes. It has a pressure vessel inside, which is sort of like a big black bag that contains all the air and pressure that you need to stay alive in a suit. It has a backpack, which has all the life support systems. It has the oxygen in it. It has a cooling system, and that takes cold water and circulates it through tubes in a long underwear type garment. And that can be adjusted from full hot to full cold, and full cold is very cold. It's about 39-degree water running through your underwear, and so it can cool you off in a hurry if you need that much cooling. The helmet is on the inside is just like a bubble, like a clear bubble over your head. But in order to protect it, you have a shell on the outside of that covers the back side of the helmet. There's a visor that you can rotate down to cover your whole face that cuts out the light that's getting to your face, and also actually can provide some warmth.
Okay, coming straight on up. Looking real good.
We have radios inside because you can't talk to your buddy even right next to you because there's no air. The suits are not designed like the Apollo suits, which people had to walk in. So these suits that we wear on the space shuttle have boots, but they're certainly not sturdy enough or made to walk in. Also, the way the legs move are not conducive to walking. So you wouldn't want to take this suit to Mars. You'd have to design a different one for Mars, but this one works quite well on the space shuttle and keeps us safe and warm and comfortable and allows us to do our work.
Ready for lunch?
With all our exercise, I'm starving. What's this?
It's dessert. Dehydrated ice cream.
What's the main course?
Dehydrated hamburgers. Sounds yummy, huh?
Sounds like a lot of chewing to me.
Well, it's a typical astronaut meal. When we're in space, we must be prepared to live and work in a weightless environment. Everything will be a challenge, like eating a meal, sleeping, shaving, washing up. Then there's using the bathroom.
Let's not go there.
Oh, toughen up. It's no big deal. An air tube suctions the waste away from your body. We're also going to have to exercise every day to counteract the effects of working in a weightless environment. Because without gravity, muscles weaken and bones lose calcium.
I'm ready.
Did you know that astronauts are about an inch taller in space than they are on Earth? That's because gravity is not compressing their backbones. Also, their muscles relax because they are not needed to hold themselves up against the downward pull of gravity.
Now that we have the space shuttle, more and more astronauts are able to go into space.
That means more opportunity for us to get up there.
That's right. And as you know, astronauts use the shuttle in a variety of ways. As a lab where they can conduct experiments or observe Earth, as transportation to a satellite that needs to be fixed, or as a round-trip ticket to and from space stations.
You mean those permanent laboratories in space?
Exactly. Just like the Russian space station Mir, an early space station. Mir means peace in Russian. The size and shape of space stations can change by attaching new modules and detaching others. Over 60 astronauts worked on Mir, including 5 American astronauts and 1 Japanese journalist. In fact, some astronauts stayed on board for over a year.
A year? Uh-oh. I don't think I packed enough underwear.
Space stations are the way of the future, Malcolm. In fact, the 21st century will see the operation of the International Space Station, where astronauts from all over the world will work together to unlock the mysteries of space. To have the edge on the other astronauts, we should begin learning Russian, just in case we get assigned to a space station along with Russian cosmonauts.
Welcome to learning Russian. To greet someone in Russian, you say, Privyet.
Privyet.
Welcome to learning Russian?
Well, Malcolm, learning a language is just one challenge of many astronauts can face. But probably the biggest challenge to space exploration is the immense size of the universe. Most of the objects in space are hundreds or thousands or even millions of light years away from planet Earth.
A light year? Isn't that the distance light travels in 1 year?
Right, and nothing travels faster than light, which moves at 300,000 kilometers per second, which is 186,000 miles per second. So let's say we wanted to visit Proxima Centauri, which is the closest star to Earth, not including the Sun. Well, it's 4.2 light years away. So that means if we wanted to visit this star in person, and we could somehow travel at the incredible speed of light, we would still have to travel for over 4 years to get there.
Count me out of that road trip.
That's why we depend on other tools to help us explore deep space. Take the Hubble Space Telescope, for example. It was the first telescope to be launched into space. The Hubble telescope can see objects in space 10 times more clearly than even the biggest telescopes on Earth, because its view is not distorted by particles in the Earth's atmosphere.
Wow, we've sure come a long way since Galileo first looked through his little telescope.
And that's not all. These days, we can also explore things we can't even see.
Lost me there.
I'm talking about all the invisible energy that radiates throughout our universe. You know, like gamma rays, ultraviolet rays, X-rays, and radio waves. We need special instruments to detect this stuff. We use big radio telescopes to listen in on radio waves coming from objects in deep space.
And what are we listening for exactly?
Well, among other things, we're listening for any other life forms that may be out there in the universe.
So what have we heard?
We've heard plenty. There are all kinds of natural signals coming from space. Still, we haven't heard anything yet that shows signs of intelligent life. But again, space is enormous. And even with all of our advanced technologies, we've only scratched the surface of exploration.
Just how far can we travel in space? We can travel to the moon. It's 384,000 kilometers away from Earth. In a rocket, this trip only takes about 3 days. Mars is quite a bit further, but we could go there too, as long as we don't mind the 7-month trip. This is Polaris, the North Star. Can we travel there? Don't think so. It's more than 700 light years away from Earth. And this faint, tiny dot is actually the Andromeda Galaxy. It's 2.2 million light years away. Even if someday in the distant future, scientists learned how to travel at nearly the speed of light, it would take us over 2 million years to travel to this neighboring galaxy.
You know, Malcolm, every time astronauts go up in space, it's tremendously risky.
You're not chickening out, are you?
Oh, no way, no way. I'm so psyched to get out there, but there is a reality to all of this. Being in space and even the launch itself can be dangerous. One of the worst space disasters in history happened in 1986. 7 crew members, including for the first time a teacher, boarded the Space Shuttle Challenger. Everything seemed okay at liftoff, but just 73 seconds into Challenger's flight, disaster struck.
Engines throttling up, 3 engines now at 104%.
Challenger, go and throttle up. Challenger, go and throttle up.
The space shuttle plummeted to the ocean and all the astronauts perished. The Challenger shuttle disaster shocked the world and shut down the shuttle program for nearly 2 years while NASA engineers reviewed all systems. Still, safety remains a major concern of any space mission. So satellites often travel into space instead of humans. Satellites have to be assembled in a completely protected, dust-free environment. This is because even the smallest speck of dust can affect the operation of these precise instruments. Once the satellites are built and ready to go, they can be launched into space and placed in orbit by rockets. They can also be loaded onto the space shuttle's cargo or payload bay. Once in space, the shuttle deploys the satellite into orbit. There are all sorts of satellites currently orbiting the Earth today. Communication satellites, weather satellites, and navigation satellites, just to name a few. Other types of unmanned spacecraft are called space probes. Space probes are robot-like machines that have given us invaluable information about the sun, moon, and other planets in our solar system. They gather information that is impossible to collect from a telescope on Earth or in space. For example, in 1997, the Pathfinder space probe landed on Mars. It deployed a tiny rover called Sojourner, which took pictures, measured atmospheric conditions, and collected soil samples of the Martian surface.
Many of the tools and other items invented for space research have been adapted for non-space uses. Some tennis shoes use special padding invented for space boots. And special protective paint invented by NASA has been used to paint the Statue of Liberty. NASA also developed special digital technology to make satellite transmissions much clearer. Now this technology is used by firefighters who use digital imaging sensors to find the fastest ways to put out large forest fires. And this same technology has been adapted to allow kids to get quick and effective digital eye tests. Pretty great that space exploration has given us so many cool inventions. Any word from NASA?
Shh! It's the library. All your space exploration books are overdue. And wait. Yes? I think this may be it.
We got a mission?
Watch out, space, 'cause here we come!
Okay. Quiz me one more time. I got this stuff down pat.
All right, how do we explore space?
Well, we can do several things. We can look through Earth-based telescopes or use space telescopes for an extra clear picture of deep space. We can listen into space activity by using giant radio telescopes, or we can go into space ourselves. But first, we need a powerful craft like a rocket or a space shuttle to overcome the pull of Earth's gravity. We also have many unmanned missions in which satellites or space probes do the exploring for us.
Okay, are there any limits to exploring space?
First of all, space is a challenging environment for humans. There's no air, no sound, and extreme temperatures are everywhere. Secondly, the immense size of the universe and the extreme distance of faraway space objects makes it hard for us to study them.
Here's another question. What was the space race?
That was the race to be the first to put a human in space. The former Soviet Union put the first satellite and human in space, and the United States put the first human on the moon. Today, astronauts from around the world are working together on international space missions where we can unlock the mysteries of the universe together.
Finally, how much of the universe have we explored?
Not very much. For hundreds of years, all we could do was look through telescopes. And we've only been traveling in space for a few decades. There's just so much left to explore and discover.
This is our mission? Space adventure birthday parties?
Okay, so it's not space exploration, but it should be a real adventure. 3, 2, 1. Ah! Quick, run! We've been set up! It's an ambush! Ambush! Run for your lives! Ah! Oh no! Oh, there goes the cake! Come back here, Stanley!
Malcolm, where are you? Let's get out of here!
I don't want to do this anymore, Stanley!
Malcolm!
I've changed my mind!
Malcolm, where are you going?
I don't know! This isn't a proper place for us astronauts.
Over here. This way, Malcolm.
Okay, no, wait! Ah!